Hi everyone, thanks for looking at the video. Today we're going to be discussing parallel lines and transversals. So just to recap what we did yesterday, we were looking at angle relationships and trying to figure out angle measures based on those relationships. As we see here in this example, we don't have a lot going on. We have some angles, no numbers, no just degree measures, and some algebra and some other angles. So if we start, it's hard to tell where to start, but let's just start with the, the most straightforward piece. This marking here means 90 degrees. So I always recommend writing, whenever you see that, writing in 90, because that might make a little more visual assistance for you. And then we see that we have two angles over here. So AOB is a straight angle. That is 180 degrees. So I know that this angle, and this angle all together add up to make 180. If this is 90, that means that this angle over here also needs to be 90, meaning this and this piece together need to combine to make 90 degrees. So we can write an equation. We can say x plus 8 plus 2x minus 8 equals 90 degrees. That's the geometry piece. The rest is simply algebra, combining like terms. So let's see. X and 2x makes 3x. 8 and negative 8 cancel each other out. Divide both sides by 3, and we get x is equal to 30. Anywhere I see an x in this diagram, I can substitute in 30 and figure out whatever measure I'm looking for. So I see an x here, plus 8, 30 plus 8 is 38. I see an x here, 30 times 2, because there's an invisible multiplication. 30 times 2 is 60, minus 8 is 52. As a check, this and this should add up to 90. They do. Cool. Now, where do we go from here? Well, I'm just going to use green. We have these two lines are intersecting. This is 52. So y needs to be 52 also, using vertical angles. Same deal as before. X is 30. 30 times 4 is 120. Minus 24 should give us 96 degrees. Now we can figure out this one here. We know that this is another same thing as the top side. These three added up to make 180. These three also need to add up to make 180. Okay, so 52, 96. Let's take out a calculator. 52 plus 96 is 148 degrees. 180 minus 148 is 32. I know that this has got to be 32 degrees. Okay, so what do you call two lines that do not intersect? Well, two lines that don't intersect are parallel. How do we show that? As a reminder, well, we have two lines and we have these little arrows here that show that they're parallel, or sometimes you'll see them written as not triangles, just kind of like arrows like this. Both of them mean the same thing. And in this particular picture, we can notate line AB is parallel to line CD. Looks something like that. And then we have this other line that's going through those parallel lines. Let's talk about that. Transversal. If we have two parallel lines, or just two lines in general, we're going to be concerned with parallel lines, but two lines in general, the line that goes through them is called the transversal. In this particular example, we have parallel lines. It's going through, transversal. This one, the lines are not parallel. If we extended them out, eventually they'd intersect, maybe somewhere around here or so, but we still have a transversal anyway. And notice that inside the two lines is the interior space, outside is the exterior space. So, where's the transversal? Which one of these is the transversal? Remember, transversal cuts two or more lines. So in this case, line T is a transversal because it's intersecting line J, line K, line M. Again, the space inside the two lines is the interior space. The space outside the two lines is the exterior space. So there are special relationships when we have transversals, okay? First we have alternate interior angles. If you think about street parking, alternate side of the street, pretend like this is the street and alternate sides would be on the left side and the right side. And we're not going to use adjacent angles because we know those are supplementary, so we're not going to use those ones. We already know that angle relationship. So let's look at interior angles. Well, which ones are interior and alternate interior? So let's look at angle 3, right here. Alternate means other side, and it can't be this one because these are supplementary, we know that. So farther down, also, excuse me. Also interior on the other side is 6. So angle 3, and wow, that's terrible. And angle 6 are alternate interior. Are those the only ones? No, 4 and 5. So angle 4 and angle 5 are also alternate interior. Same principle for alternate exterior. Here's one on the outside. On the alternate side, well, it can't be this one because that's adjacent, right? So we go down here, 8. So 1 and angle 8. Yikes. Still getting the hang of writing on this. Okay. 2 and 7 are also alternate exterior. Same side interior. Well, now we're talking about the same side. So 4, and instead of alternate, which would be on the other side, we're on the same side, and we're inside. So 4 and 6. What's another pair? 3 and 5. Same side exterior. I think we can tell. 1 and 7. 2 and 8. Okay. What do you think happens with those relationships, alternate interior, alternate exterior, when we have parallel lines? In other words, what do you think this obtuse angle 4 and this obtuse angle 5? Well, they look like they're congruent, and it turns out that they are. We never want to ever go with they look like they are and that's good enough. They are, and we can prove it. We'll handle that another time, but right now, alternate interior angles are congruent when the lines are parallel and they're cut by a transversal. Alternate exterior angles are congruent. Same side interior angles, like 4 and 6, they can't be congruent because one's obtuse, one's acute. 4 and 6 are supplementary. They add up to 180, and the same holds true for same side exterior angles. Corresponding angles. So here we have our two parallel lines, and here we have our transversal. Corresponding angles are in the same relative position. So here's one intersection with 4 angles. Here's another intersection with 4 angles. And notice that 1 and 5 are both in the top left-hand corner. This is an obtuse angle, this is an obtuse angle. 1 and 5 are corresponding. What do you think the case is with those two angles? They're congruent. 2 and 6 are also in the upper right of their respective intersections. So 2 and 6 are in the top right. They're congruent because they're corresponding angles. 4 and 8, bottom right, congruent. 3 and 7, also congruent. They're in the bottom left. They're both acute angles. They are corresponding angles. Okay, so if this is 120 degrees, believe it or not, we can label every single angle in this diagram. So if this is 120, what can we say about angle 4? Yep, you've guessed it, 120 degrees because they're vertical angles. If angle 1, and now we can go about this a whole bunch of different ways, but let's just go like this. If angle 1 is 120, how much is angle 2? Well, it has to be 60. They're right next to each other, so they're adjacent, right? 120 and 60 are adjacent and supplementary. They're on the same straight line. 60 goes there. This one also has to be 60 because they're vertical. Now, we filled out this intersection. How do we get down here and kind of like hopscotch around? Well, we can do this a number of ways. We have alternate exterior angles. We have alternate interior angles. We have same side interior, same side exterior. A whole bunch of things we could do. Oh, and corresponding as well. So, a couple different ways we can do this. If this is 120, top left is 120, top left over here also needs to be 120. That wasn't the only way we could have gotten that. Look at angle 4 and look at angle 5. Hey, they're alternate interior angles. They're on alternate sides of the transversal. This one's on the right, this one's on the left. And they're in the interior space of the two parallel lines. So they have to be congruent, 120, 120. Using that same reasoning, we have 120. We could do everything we did up here, saying supplementary angles, vertical angles, or we could jump around. This is 120. Alternate exterior angles, 1 and 8. This one has to be 120, congruent. We could use alternate interior here. These two are congruent, 60 and 60. And then, corresponding. This one's 60, so this one corresponds to the bottom left, bottom left. And again, that's just the way we did it right now, but you can use any combination in any order of what we did to fill out all these angles. Okay? Basically, it's all these angles copy all down here. That's one way to think about it. So we're given that the measure of angle 4 is 73 degrees, and what should be here, sorry, I must have left it out, is that we had parallel lines, right? So we have parallel lines, 1, 2, 3, 4, 5, 6, 7, 8, and take a few minutes, fill this out, see what you get. Okay, more to come tomorrow. Thanks for checking out the video. Make sure to pop back in frequently to see some updated video and look at material that we've covered in class. Thanks.